Morning all of you. Now consider when we consider this table, that is how in the case of a pyramids or prism, all of you know what is the difference of prism and pyramid. Okay, for a prism both base and top, okay, that will be congruent. Okay, so in the case of this is a pyramid, you can see this is a pyramid, that is one end on the top it will be only one vertex. That type shape is pyramid. And pyramid also have different types of pyramids, that according to their base, this is which shape, according to their base shape we can decide their name. Here what is the shape of this base? Square. So we can name this square pyramid. Okay, so another types of pyramids also there. If it is a triangular, here base if it is a triangle, and just like this top one vertex, that we can call triangular pyramid. Just like if it is a another shape or with 5 sides, then pentagonal pyramid. If the base side is 5 sides, then and if like this one vertex, we can call it pentagonal pyramid. And prism, what is the difference of prism? Prism on the top and bottom will be same congruent shape, and these lateral faces, these side faces are called lateral faces. Lateral faces with the rectangle shapes. Okay, that is called square prisms. That's like prisms, different types of just like pyramids, different types of prism also there. According to their base we can decide their name. Now one example for a prism, this shape we can take as a prism. Now both top and bottom is square shape, and lateral faces are rectangles. These faces are called lateral faces. Okay, and this is bottom and top. Here top and bottom is which shape? Square shape. So we can call it as a square prism. Just like if it is a another shape, triangle, if this shape is triangle, and just like same, and here also top also triangle, then we can call it as triangular prism. Okay, so if we consider this table, if we count the number of faces, and here one column also there for paper faces also we want to make one column. Okay, number of faces, number of vertices, and number of edges. After that, when we take the sum of number of faces and vertices, and with the number of edges, when we add 2, what we will get the result we can check. First we can consider cuboid. Cuboid, all of you know which shape, this type of shapes are called cuboid. How many faces are there for cuboid? So lateral, how many faces? 4 faces, and bottom 1 face, and bottom or base, we can call it as base, and top. Total 6 faces are there. And how many vertices? Top 4 vertices and bottom 4 vertices, so 8 vertices. Edges, here edges, you know this line segment, just like here 4 line segment, 4 plus lateral 4 edges, and here 4, so 12. Now find out f plus v, 6 plus 8 we know that is 14, and e plus 2, e is 12. Number of edges we got 12. With this, when we added 2, we got 14. Now in the case of triangular pyramid I told you this like not pyramid is this square pyramid. Just like instead of square, if it is a triangular pyramid, then how many faces will be there? That we can count. Triangular pyramid. On the base, 1 face, and on the bottom, how many? On the lateral, how many faces? 3. So it is 4. Triangular pyramid, number of faces 4, and number of vertices. Number of vertices, bottom 3 vertices, and on the top 1. So that also 4, and edges How many edges for a triangular pyramid? On the base, 3 edges will be there, and the lateral 3 edges will be there. So total 6 edges. Okay. Now f plus v. What is f plus v? 4 plus 4, 8, and e plus 2. 6 plus 2 we will get 8. So just like this remaining part you want to fill. Okay, for a triangular prism, what will be? This is for triangular pyramid. Pyramid and prism difference you understood. And triangular prism, both the top and bottom will be triangle shape and the lateral faces rectangle shapes. And find out the faces, vertices, edges, then find f plus v and e plus 2. In all these cases, we can see the sum of the number of faces and vertices will be equal to when we add 2 with the number of edges. Okay, so we can, in these all cases, we will get f plus v equal, this you want to fill, f plus v equal e plus 2. Okay, f plus v equal e plus 2. So this is called, this formula is called Euler's formula. Euler's formula. Okay, this is called Euler's formula for solid shapes. Okay, in any prism, any polygon, this is true for any polyhedron. Okay, not polygon, for any polyhedron. All of you understood what is polyhedron, and this is true, this formula is true for any polyhedron when we take, that means number of faces and vertices when we add, we will get e plus 2, number of edges plus 2. Okay, now in this textbook 2 questions are there. We want to verify Euler's formula for the given figures. Okay, here 2 figures are given, just like 5 faces are 1, 2, 3, 4, 5 faces are there, and you can see the same figure in the textbook. Okay, and other also there. Okay, this some more correct face we cut. Okay, this shape, this type of one figure is there. Verify Euler's formula for these solids. So first you want to find out how many faces will be there. You can see the same figure in the textbook. Look at that. Then how many faces will be for the, so just then you count what is its top and base and which shape. That is a pentagon. Okay, so there will be top and bottom 2 faces. Then lateral, how many faces will be there? 5 faces will be there. So 5 plus 2, 7. F we got 7. Number of faces we got 7. Just like how many, what it will be V, number of vertices. On the top, how many vertices? 1, 2, 3, 4, 5. And the bottom also 5 vertices. So number of vertices will be 10. Now edges, top 5 edges, bottom also 5 edges. Okay, so 10. So lateral, then lateral edges also there 5. So 15 edges are there. Okay, now find out f plus v. F plus v is equal to, what is 7 plus 10, that we will get 17, and e plus 2 we will get, e is 15, 15 plus 2 we will get 17. So we got here f plus v equal e plus 2. So we verified the Euler's formula in the case of this solids. Just like one more figure is there. All of you find out, verify that Euler's formula for that given shape. Okay, thank you.